Okay, today we're learning 2.5 scientific notation. Like I was saying, scientific notation is a shorter way to write really big or really small numbers. Here's the number one rule for writing a number in scientific notation. Your number, your value has to be greater than 1 but less than 10. Okay, your decimal value. The number, this stands for the number that you're writing in scientific notation, has to be bigger than 1, but less than 10. That's your rule. So you move, where's the decimal place in 110,000? Where's the decimal place? It's after the ones place, right? If it's not written, okay, if you don't see a decimal in the number, the decimal is after the ones place. So I'm going to move my decimal to a value that gives me a decimal value greater than 1 but less than 10. So I go all the way. If I put it here, does that give me a number greater than 1 and less than 10? 11? Is that in that range? No. Nope, I have to go one more. Is 1 and 1/10 greater than 1 but less than 10?
Yes.
Yes, it is. So I'm going to say 1 and 1/10 times 10 to the however many decimal places I had to move my decimal to get to my new number. So I went 1, 2, 3, 4, 5, so 10 to the 5th power. And that is how I write the number in scientific notation. All right, so now let's look at the next one. 1,350,000. Okay, where would we place our decimal? Could it go here? 13 and 5/10. Does that give me a number greater than 1 and less than 10? No. Where does my decimal need to go?
It needs to go between the 1 and the 3.
In between the 1 and the 3. And 9 times out of 10, guys, that's where your decimal place is going to go, between the first and second digits. All right, but now my decimal value is going to be just 1 and 3/10. That's it. 1 and 35/100. I have to include all of the numbers that are there. I have to include all my numbers. So 1 and 35/100 times 10. And remember, we find what our exponent is by counting how many decimal places we moved. 1, 2, 3, 4, 5, 6 times 10 to the 6th power. All right, now I want you to try the third one. All right, Dylan, what's it going to be?
4 and 5/10
Times
10 to the power of 3.
Perfect. Times 10 to the power of 3. So it's 4 and 5/10 because, again, is that in my range? Greater than 1 and less than 10? Yeah, it is. And then I went 1, 2, 3 decimal places, so times 10 to the 3rd power. All right, and that's how I write a very large number in scientific notation. All right, now in example 2, now I'm going the other way. So now I have a number written in scientific notation, and I need to expand it. So I have the number 7, and my exponent tells me how many decimal places I'm expanding my number by. So since it's 3, I'm taking my decimal from here, and I'm going 1, 2, 3, and I fill in my zeros. And so what's my new number? 7,000. I want you to write a clean number and box it in. So you can do the little swoops like I did, moving your decimal, but I want a clean answer, so I want you to rewrite your new answer, 7,000. Now let's look at the next number. I have 4 and 398,000. How many decimal places am I moving this number?
8.
Expanding. 8. The exponent tells me how many decimal places I'm moving. So I already have some digits in my decimal. 1, 2, 3, 4, 5, 6, 7, 8. And I fill in my zeros in the troughs. All right? Don't forget your commas. Once you can see the number, then you're going to rewrite it. Give me a clean number, 439 million. Don't forget your commas. And that's how I write a number in expanded form. One more example. All right, so now I'm going to compare numbers in scientific notation. All right, so we're comparing numbers in scientific notation. If I'm comparing 1 and 600ths, I'm going to bump it over, 1 and 600ths times 10 to the 16th power to 2 and 4/10 times 10 to the 15th power. Okay? Well, I don't really want to multiply all that out. There's a short and easy way to compare numbers in scientific notation. The first thing you want to do is you want to compare the exponents. Look at the exponents. If the exponents are different, it's as simple as which exponent is bigger? 16, so it's greater than. Okay? If the exponents are different, it's a really easy answer. The bigger exponent is the bigger number. But if your exponents are the same, let's say it's 2 and 2/10 times 10 to the 8th power compared to 2 and 7/10 times 10 to the 8th power. Now, both of my exponents are the same, right? They're both 8s, right?
Yes, ma'am.
So since they're both the same, I need to now look at my decimal values. And which decimal value is greater? What?
2 and 7.
Very good. 2 and 7/10. So obviously I would write a less than sign there. All right, so simply put, guys, comparing numbers in scientific notation, I look at the exponents first. Bigger one is the bigger number. If they're the same, I compare my decimals. Questions so far? Now, what if I was comparing 9,800,000 to 9 and 7/10 times 10 to the 6th power? Can I tell which one's bigger? Can I just say, oh, yeah, that's easy, 9,800,000?
Nope.
Because they're not in the same form, right? One is in expanded form, the other one's in scientific notation. So here's the deal with these. You can do it either way you want, but you've got to compare. So if you want to change 9,800,000 to scientific, you can do that. Or if you want to change 9 and 7/10 times 10 to the 6 to expanded, you can do that. I prefer scientific notation. So I'm going to change it to 9 and 8/10 times 10 to the 6th power compared to 9 and 7/10 times 10 to the 6th power. And now, which one is bigger? Which one's bigger, guys? Yes, 9 and 8/10 because my exponents are the same, but my decimal value is greater here. So that's going to be a greater than sign. All right, any questions on comparing numbers in scientific notation? Okay. All right, if you understand that, that's everything you need to know for 2.5.